Good morning and welcome to IdentityShield 2025. This is the first session of the day that you are attending. And from the topic, as you can see, we are going to talk about some vulnerabilities, some applications, secure coding. But before I get into all of that, let me just go right into um, talking a little bit about myself. My name is Pratish. I'm a principal engineer here. I head the IM team with a couple of more folks. And I'm an IM expert. I've been working in the industry for cybersecurity domain for the past 10 years. I love to code. And I'm generally good at being able to debug any issues that crops up. That being said, I just wanted to see few hands. How many of you are developers here? Okay, software developers. How many of you are testers, QA engineer, automation engineers? Okay, how many from DevOps, DevSecOps? Okay, a good general mix. Okay, so I wanted to just give my opinion on what type of developers I have seen in the past, so many years that I've been working, reviewing PRs, reviewing code, looking at code. So we start off with, let's say there's group one. Usually they're early stage developers, maybe from college or school days, where this is like, write code for the happy path, which is A plus B equal to C. Okay, I only will do A plus B equal to C. That's what my program will output. It won't take care of any other inputs. The next stage or next type of developers are usually, they start looking at, okay, how do I write better code? They look at performance, they look at optimizing the code, they look at solid principles, scarce, dry, all those principles, design patterns, they start applying all of that. So generally good set, maximum people are here. But very rarely, you have a third set of group of developers who actually look at code from a security perspective, look at secure coding, and we tend to miss a lot of things while we are working. Like you will see a lot of examples in the session today, which will cover all of the, which will actually give you idea in terms of what you actually miss. So with that, what's the agenda of this session? Well, what you'll get to learn, first is a general knowledge in terms of the common mistakes. I'll call them mistakes. I'm not going to cover OWASP top 10 because that is something which all of you guys can actually Google and read about it. What I'm going to focus on are the mistakes that I have seen actual developers make, which actually result in some of the vulnerabilities that we are talking about, like SQL injection, cross-site scripting, and all of that. What you will learn is how to better secure your applications. You will learn about how to catch some of these issues in development and testing. You will learn about how to use some of the open source tools. I'll give some recommendations. The rest is on you, what you want to implement, because there are a lot of them. And be, in general, a secure coding champ by the end of this session. And when you go back, you're able to feel that, okay, that was a good session I attended, take something back and actually implement it. Okay, so with that, let me just jump right in. And let's start looking at some mistakes usually developers make, or usually what gets overlooked. This is a simple form, right? You have first name, email, phone number. Basically what this form is doing is, it's updating the email address in the backend. That's what it is doing. So let's look at the code a little bit. I hope it's visible. If it's not, just raise your arms. So here is the first layer. This is a service layer. If somebody has worked in Spring Boot in Java, I'm assuming everybody has because it's microservices. So simple enough. That's an update email endpoint. You look at user ID, you're taking user ID, you're taking email address, and then you call a function called update customer email. Okay, straightforward enough. Let's look at the update customer email code a little bit. From what you can see, if you can see, we are connecting to the database. We are running a query. We're generating the SQL query and then running that query. Straightforward enough. Okay. Does anybody see, if you can raise your arms if you see any issues with this code? Okay, I see a couple of hands going up. All right. So what's wrong with this code? Let's look at what happens if I give it a certain input. What happens if I give this as my input? Especially looking at the email address field. I mean, those who raise hands, if they were able to guess this input, good enough. If not, you can maybe take this away, like take this as something which you can use in other applications just for testing. Okay, so what happens if I give this input? Well, first, let's look at what will happen if it runs through the code. Especially, let's look at this area, which is when we are generating the SQL query. Email address, we can see that it's appending something to a string to generate the SQL query. So what happens is the SQL query becomes something like this, which is update users set email equal to my email address, and then drop table users, and everything else gets commented out, right? So, oh shit. Drop table users, my entire user table is now gone. Now that is something which runs from the front end. Like as a developer, you did not think about it, it got missed, but somebody injected that into your email address field, and now your entire users table is gone in the database on production. SQL injection, right? But it originated from where? Not actually thinking about your code and looking at your code and then figuring out that, okay, I should not directly take anything from input without sanitization or without any sort of validation and use it in my string query for generating my SQL. Like this was a code for updating email addresses. At the bare minimum, there should have been a code for checking if the input, the email address input that was given was actually a valid email address. You can actually check this. That's what's missing in this code. There's no check for checking that, the email address field is actually a valid email address. Okay, let's look at some more examples. This is again simple service class. You in Java Spring Boot, you have one endpoint which saves input, is adding to the database, and then you have another input which is actually fetching something from the database, right? So now the question is, there's another set of code. This is HTML and JavaScript. So this is a JavaScript code which is on an HTML page. I have just trimmed it a little bit so that it's visible. What is the JavaScript code doing? It's fetching something. It looks like it's fetching the items, and then it's getting document.getElement by ID, which is list, something in the HTML code, and then appending it to the DOM, or the document of the HTML that you have. So what is wrong with this code? It's a little similar. If you're getting the gist of it, if you understood the last example, you might be getting an idea. Can everybody raise their arms if they are able to figure out what's wrong with this code? Okay, I see only one. It's very similar to the last one. Okay, let's look at an input that we can give. So let's say there were two endpoints. One was to save to the database, and one was to fetch from the database, right? So this one is to save the item to the database. So what am I doing? I am sending an HTML code as my input to be saved in the database. Okay. Now when I fetch it, if I run that code, this is what is going to happen. So I ran it, and now because I was fetching item from the database and my database had that script already in the database, I was able to execute a script, right? And I execute a script without even having to do anything like sort of any gizmo, just making sure that I call that endpoint and save a script. I'm able to save a HTML script which I can then run later on. What this is called is basically cross-site scripting, if people know about it. This is being able to inject a code on the HTML from some input that you gave earlier. Okay, let's look at how is this happening. This was my initial service level code, right? Now what we are not doing here is actually, again, simple enough. Just like the last example, there was no sanitization. Like there should have been a check which says that, okay, I do not need users to be able to save HTML code, because in my JavaScript, I'm directly appending it to the DOM, right? Then Again, same thing with while fetching from the database, there was an assumption that everything that comes from the database will be pristine and it will be error-free and there'll be no issues with it. Even if we look at the HTML code, there's one issue there, which is we were directly injecting, like we made an API call, while and whatever response came in, I was able to accept that and then just directly injected that into the HTML document without any sanitization, without any validation. Now the issue here is that as a attacker, if I see this code, I can modify your code in the response as well, what we call as man in the middle, right? So there are multiple levels of issues with this. Okay. But we all are new age developers. We don't do HTML, CSS, JavaScript. We do React. Okay, let's look at a React example. Let's see, this is an endpoint, again, which actually gets your capabilities from the dashboard, from the backend. Anybody, how many of you are React developers or have built applications in React? Like at least have seen and built, like just raise your arms if you have worked in React. Okay, very few. Basically, nothing. It's just we are making an API call and getting something back to show some components on the UI, right? So that's the entirety of how React works. Now, in this case, what we are doing is this is a list of capabilities. I'm making an API call from the front end to get the capabilities, and based on those capabilities, I'm going to show something to the user. Now, as a user, you can be the different roles. Like I can be an admin. You guys can be users. Now, as a user, I should not be able to see what an admin, the admin pages or the admin components of React, right? So we wrote a code which is, let's say, I fetch the capabilities, and if the user has those capabilities, I will show them on my the component, or based on that, I will show what in the dashboard, the admin or the user section. This is a React code. I have trimmed it down. This is not the entirety of it. But basically what we are doing is, again, same thing like the HTML. We are making an API call. And based on that, we are then have a check which says, if you have the capability, then render that section. OK. So straightforward enough. Everybody understood that? Now, my question to everybody here is, what is wrong with this code? You can raise your arms if you're able to figure out what is wrong with this code. Okay, nobody? All right, let's take another look at the code and then figure out what is wrong. Actually, there's something wrong with the implementation. There's nothing wrong with the code. It's about not doing something. We are assuming that when we make the API call and whatever response we will get, we are then, based on that, checking that, okay, the user has this capability and then rendering that in the UI. Now, over here, in the last example, you might say that, okay, man in the middle is tough. We are on HTTPS. It's SSL, very difficult to, do man in the middle or whatever. But in this case, there's no man in the middle required. I am a user. I can see this code in my browser and modify it as I want it. There's nothing happening here. Nothing man in the middle happening here. But what I can do is, as a user, I can manipulate that JSON. I can manipulate that JSON to, let's say, have admin capabilities. Before it goes to the browser and the rendering, everything happens, I can do that because React, everything is happening on the browser, right? So let's say I manipulate that JSON and give myself admin capabilities. What do you think is going to happen here in this code? I will be able to see all the admin components which I did not have access to. Now, the next step over here is, let's say I, as a developer, relied on the fact that my front end will not show admin capabilities and did not have any backend check. Let's say there is a section of, let's say, updating any user details that only admins have access to. Right, and then I relied on the fact that, okay, if they don't have capability, they won't see it. So I don't have to worry about, like, is the end user able to make a call to updating the user details. So in that case, if there is no validation, over here we just saw that, okay, I can render it, but maybe I can even go ahead and then execute the admin, the section or updating the user or the admin feature sets, and then do a privilege escalation. In this case, I have seen this happening a lot, wherein in terms of React, we rely on a lot of wo kar dega ya fir somebody else will handle it. We should always assume that this is not handled on the top layer and always have validation in place. So all the examples that we just saw all have one common theme. There is a lack of improper or there's a lack of input sanitization or validation in all the three examples that we saw. That is the first and primary level mistakes that I see software developers doing, especially if there are multiple students here. You need to have that mindset of thinking about this. We usually just go ahead and code, but we don't think about what do we need to sanitize. Do we need to sanitize our requests, inputs? Do we need to validate if it's like something to do with email address or something to do with strings? Do I need to do any sort of validation? So all those things, usually if we miss, leads to a lot of the top 10 vulnerabilities that we talk about. We looked at the SQL injection example. Then we looked at the React example, which was breaking authorization. We were able to bypass authorization of what my capabilities were, and then able to execute admin operations. We looked at cross-site scripting, the HTML example, and then even do remote code execution if you want. So that's the primary level mistakes that we do. Okay, let's look at another example, which usually is not talked about. We all know that the internet, all applications work based on session IDs, right? The cookies. Cookies is something which is how authentication is managed in most of the applications. How many of you have tried copying that cookie to another browser? Let's say you logged into Facebook or you logged into some application, and then you copied the entire cookie of that website to another application, another browser. What do you think happens? Let's say I'm logged into Facebook. I took all the cookies and then exactly injected those cookies in the browser on another machine. What do you think happens? Any guesses? Yeah, you can speak up. It's fine. Yeah.
Of the user,
Yeah.
then it will allow the session.
Correct. Yes. Yes. So session hijacking happens, right? So that's the entirety of how cookies work. Like if there's no validation on the backend in terms of which device or which, there's no context awareness, like Sir said, then that leads to session hijacking. So that's what I'm going to talk about. That is something which usually gets missed by us because we rely on a lot of libraries and a lot of existing code to be like, okay, I don't have to think about this, but you actually need to think about it because the default in most of these libraries, they don't take care of like security at all. So let's look at the same scenario. What I as an attacker can do is I can set a session ID or get your cookies. Using cross-site scripting or whatever, I can get your cookies. And then when you actually log in, you go to log in, your session or those session IDs that you have, usually session IDs are generated as soon as you land on the page. And when you log in, most applications, they don't change that session ID. So as an attacker, if I have access to your cookies, I have access to your session ID, I can very easily get access to your session, right? Just like somebody said, I can do a session hijacking. This is something which is called as session fixation, which means before, like if I am an attacker, what I can do is I can send you a link, a phishing link, which is actually setting a J session ID if you're on Java, or some session ID on some other application, based on which framework and library you're using. And then based on that, use that same session ID and hijack your session. So what you should actually do in this case is actually you should change or regenerate the session ID after login. This is usually missed by many of the, when you're building your application, this like usually you don't think about it. Like you just, it's not there in your mind at all. You're just focused on actually building the authentication. Username, password, and then credentials match, yes, go in. But you should actually regenerate the session ID so that in case, even if something like this happens, the attacker won't have access to your cookies or your session ID because it got changed. They were not able to, whatever this tried to set was actually changed. What you should also do is use secure cookies. This is another concept. It helps prevent some, any third party being able to access your cookies, either via phishing or either via, cross-site injection or whatever. And then you have to set session expiry. Please do not set it for lifetime or set it till 2035. Have session expiry, good session expiry, and make sure you are limiting your scope. Scope in the sense you can, like Sir said, have a little bit of validation in terms of where the user is actually using that particular session, and then see if that is changing. And if that is changing, then your system can behave in a way where it can reject that you have already logged into some other session. You cannot log in here. So that's another, I think, the second one which usually gets missed. Time to look at some more code. This is a PHP code. Any PHP developers here, or that's now old age and nobody codes in PHP anymore? You can raise your arms if it's fine. Okay, I see one. Okay, simple enough PHP code. I'm taking username from request. This time I am doing sanitization, and I am doing something called as a CSRF token validation, right? So good enough, right? Like looks legit, but there's something wrong with this code. Anybody can guess what? Anybody? Because I asked, like, one person here worked in PHP. Are you able to figure out what's the issue with this code? I think somebody raised their arms here. No? Okay. Let's take a little bit deeper look into what the issue with the code is. What if I pass this, which is a get parameter? I'm calling, like, my file is hosted on a localhost test.php, and I'm in my username because we are taking username. I injected the script. What do you think how would the system behave? Any guesses? Yes. But I'm doing sanitization. There is sanitization in place. Any guesses? Well, we will still have cross-site injection. Why? The question is why, right? Why? We are not storing anything. This is just plain. There is sanitization happening, so there is no way. Like even if I inject a script, try to inject a script, the sanitization should have taken care of that. Okay, let's look at why. Let's look at this code again a little bit. Let's look at this particular code. $_request, right? $_request is like catch-all. You do post request, get request, put all the different type of requests that you can do. It will have all the variables in it, as this is PHP specific. Okay. But what we are doing here is we are validating our CSRF token and our sanitization only on post. So usually what happens is, let's say I'm writing the piece of code. I understood that CSRF token can only be applied on post requests. I don't want it to execute on get requests because usually CSRF token does not. There's no token as such in get recalls, right? So initially I had just that code. Then somebody came in, new developer. They said, okay, you need to sanitize because Pratish had a session. He said that you need to sanitize your inputs. I need you to sanitize my username. What he saw was, okay, there's already a CSRF token code which is there. Copy, paste, and then sanitize ChatGPT, and then done, right? Well, the issue is, because there was a $_request, I was able to make a get call and bypass both of the two security measures that you took, CSRF token and sanitization, because they were only on post. So understanding the difference between $_post and $_request and what it does in this context becomes very critical. Okay. Do you get it now? Thoda bahut? Okay. Let's look at Java example. Make it even better because I think most of you over here probably understand Java, and this is a Spring Boot one. Okay. Uh, oops. Everybody likes oops, object-oriented programming. One of the key features of that is abstraction. I don't want to worry about it because it is abstracted. So I, as a developer, I am a stage 2 developer, and I wrote this code as saying that, okay, I want to follow dry principle. I don't want to repeat myself. I will build a filter which will take care of CSRF validation, and it will also look at it will validate my authentication header, correct? So this filter now gets applied to all my endpoints, security for all. Any software developer who comes in, even if they are not implementing this particularly in their code, it will happen by itself. Good enough code, right? A filter for checking, and by default, security by design, you can say, good enough code. Okay. Um, let's look at let's say I'm a developer, I come in and I wrote this code. This is my Spring Boot API service endpoint where I have created an endpoint here which is delete account, right? What do you think is wrong with this code? There's something wrong with this code. I was a good developer. I created an abstraction by saying, okay, I'll have a filter in place. And with that, all my other developers, my junior developers, don't have to worry about it. There is security by design because CRSF token is getting validated and my authentication header is also getting validated. Anybody can guess what's wrong with this code? Yeah, please speak up. It's fine. I think you can be loud enough, I think. Yeah. Uh, Not exactly, but it will lead to IDOR. I'm just saying what's wrong with this code. Yes? Sorry?
Hello.
Validation is missing code from query string. No, I'm saying that, okay, validation is missing code for query string. We'll come to that later.
You are not validating if the user ID belongs to the user.
Let's assume that's there. There's some other issue with this code. Particularly looking at the filter part of it, like I think the person was asking the IDOR part, which is authentication will get bypassed and then you'll be able to execute something. It's something similar on those lines. Something similar to the last example, where we were able to bypass the CSRF and sanitization and everything.
All right, because it deals with GET request.
Uh-huh.
It deals with the code that you wrote there. It deals with post requests. So if you send a GET request, then it bypasses all of that.
Right. The code which has been written is actually not, but it is similar to the last example. It is catch-all. I can do post, get, delete, anything on that particular endpoint. We'll come to that. But first, let's look at our filter, okay? What is the filter? Again, same lines. I understand, similar to the last PHP example, in my post, I need to have CSRF token in place, and I need to be able to validate. Usually, CSRF tokens are used to prevent replay attacks and something on those lines. Now, this entire code is abstracted. So I, as a developer, was told by my senior that you don't have to worry about CSRF tokens and validating your authentication headers because that has already been taken care of by the filter. Okay. So I went ahead and wrote this code. Now in this code, like I think somebody pointed out, so there is no exact matching of like this endpoint should only work for delete requests, or it should only work for post requests, or it will only work for get requests. It was a catch-all. No exact method was mentioned here. So because we usually tend to write code, copy paste code, so it's very important to understand this nuance about what is happening here. So looking at the previous code, if we go back, because it was only on post, I was able to do any call, which like a get call, and then bypass this and delete an account if I want to, right? And then yes, obviously assuming that you do sanitization and making sure that the user is associated to the user ID or not, and so on and so forth. Oops. Okay. this is called HTTP verb tampering. Um, what that means is if you're not explicit, these days there's a lot of libraries, so this does not happen often, but then you have to be pretty careful in making sure that there's no bypass of critical checks or authentication. With this, if you don't manage this, then the examples that you saw, you can execute something which you're not supposed to, and bypassing authentication headers and so on and so forth. Okay, it leads to a lot of things. You can see and read about it. I think you get the idea. We'll just quickly go over more examples. This is a similar example, which is, let's say you have this straightforward code. I have trimmed it down. Don't look at sanitization and stuff. There's some SAML response coming in post request. Okay, there's some input coming in the post request of relay state. And then there's a code which says that, okay, if there's a redirect URL, then redirect the user to that URL. Right, straightforward. I think if anybody from here is in miniOrange, you probably understand this code. Let's look at the Java equivalent to it. Same thing, reading it from the request, and sending. I think most of you are probably getting the idea of it. There's something wrong with this code. Yes, if you have figured it out. The issue is that we are directly taking the input of where to redirect to, and then redirecting the user to that endpoint. And this means that I, as an end user, can modify that URL to go anywhere, or as an attacker, send you a phishing link to send you to some malicious site. Same thing here, directly taking the input and then redirecting the user somewhere else. This is called as open redirects. Now, it does not look that harmful, like you're just going to another website, like you were trying to log into some application, but because of the redirect URL, you got redirected to something else. But it can lead to some, sort of phishing attacks. It can lead to session hijacking because I can get your cookies. I can, bypass some email providers. Like email providers have this, like if you try to send any explicit, blacklisted URLs, it will block your email or, remove that link entirely. I can bypass that by doing open redirects. Like I'll have a valid trusted site, but in the redirect URL, because it's all open, you have not whitelisted or blacklisted any URLs. So I'm able to, bypass that email provider check by appending my own phishing link, sort of. Leads to brand reputation because it's all redirecting from your domain. And yeah, we can do some cross-site scripting attacks also. Okay, let's look at some more code. This is file. I think everybody here has done some sort of CSV sort of a code, which means generating CSV by reading something from the database. If you have not, you will at some point do it in your career, which is read from the database and generate a CSV. So this is the PHP code for it. And sorry, I'll put it there. Simple enough, open the file. I write something from the database. I have trimmed this down so that it's visible. And then I'm putting it in my CSV file or generating a CSV file. Same thing with this Java code. I am reading data from the database and then writing it to the file. So what do you think is wrong with this code? Like it's coming from the database. I'm assuming like everything in the database is pristine. So what do you think is wrong with this code? Anybody? Write permissions is one of them. Yes, that is true, correct. But it's not the only one. What if because if you look at the code, what it's doing is it's getting data of all the users from the database and generating a CSV, which means usually what we do is you have full first name, last name, email address, phone number, right? So what if I set this as my first name? What do you think will happen? DDoS, not DDoS. Like I'm just generating a CSV. I saved this as a user. I saved this as my first name. Now as an admin, I'm generating a CSV to check that, okay, which users have, created that account today. I generated a CSV. I open that CSV in my Excel. What happens? Well, sort of something like this. It opens a CMD and it starts pinging because I wrote like ping that IP address, so it starts pinging, which means I can execute some sort of a CMD or a PowerShell script uh, without having to do anything, just creating an account and setting that as my setting this as my first name. Usually first names don't have any sort of validations. Email address, yes. First names, no. So, yeah. This is very dangerous because if I can execute something on CMD, I can do a lot of things. So let's look at the code. Again, we are assuming the data from the database is pristine and error-free. We are, there's no sanitization before writing to the CSV file. Right now, we only focus on writing CSV, but then we are not focusing on um, actually writing in terms of like, is the CSV data valid or not? So this is what we call CSV injection. And in terms of CSV injection, I can steal any sort of data. It can lead to phishing attacks. I can execute some remote code on your laptop or desktop. It can lead to some installation of some malicious files because if I can ping my server, I can also download something on your system, right? And then it can also lead to ransomware. If I can download some file, I can execute that, and now your entire system is encrypted. Okay, let's look at, we looked at CSV generation. Let's look at file uploads. I've seen this happen a lot of times. We write a simple file upload code. In terms of file upload, we tend to miss a lot of things. This is a code, Java code, simple enough. We are writing a file to a directory on our system, on the server. What do you think is wrong with this code? Well, everything. What does that mean? Okay. There's no proper validation. If you look at the code properly, there is no proper validation of anything, of any kind. So let's look at what are the different type of validations that you can do. There was no file type validation. I can upload anything. Not like there's no validation of .csv file, .css, .js, nothing. So I can upload even a Trojan. I can install some, shell, reverse shell, anything can be uploaded. There's no sanitization of the file names. If you understand directory traversal, which means that, let's say I can do, everybody understands in Linux there is cd space dot dot to go back a directory, right? So I can probably give my file name as dot dot slash and then some other name, and then go two directories above where you want, where usually the file should get installed. So sanitization of file names usually we miss. There was no check for what type of file I'm uploading. Usually I can say that I am a .png, but actually I'm something else. You just have to change the extension of your file. There was no content scanning of the file which was getting uploaded. And there was, I think somebody mentioned here, there's no permission. Like I can even upload an executable file, right? I'm not setting the file permission while I'm uploading to the server. Like it should be only read only, right? So those sort of things. Another issue which we do is we tend to do this, which is upload secrets or private keys to GitHub. I think many of you here are students, so you probably are uploading something on GitHub as code. But let's say you do realize it and then say that, okay, let me remove it. You revert the commit and then say, okay, now it's good because I cannot see it in my Git. But actually, it is still there. It's in your Git history, right? It never goes away. If it's once committed on GitHub, on any Git directory, it's still there. It's in your history. So there's some concept called Google Dorking, which means I can search for API keys on GitHub like this using Google. Because Google indexes everything. It also indexes all of your repositories on GitHub. Try this sometime. You probably, if you're into penetration testing, you probably already know about this. Like I said, your keys are already in your Git history. They're still there. There's nothing you can do about it. Base64 encoding your keys are also not a good idea. In and all, never check on your secrets and keys anyways. Okay, with that, let's look at, I'll just quickly cover this because I don't want to go into detail into HTTP security headers. What I want you to understand is a browser can do a lot of things for you if you set a few things correctly. So let's say you have, there's something called as CSV headers. CSV headers are what type of scripts, what type of CSS are allowed, should be allowed on your website or on your application. That is something which you can set. The browser itself will deny access to any external headers that you might be setting. Then you have something called HSTS headers, which is, it tells you that there is only, your site can only be accessed via HTTPS. If somebody tries to access it via HTTP, browser will deny it by default. Then something called Xframe options, which is, should your browser be installed in an iframe? What this does is, it prevents cross-site scripting or session hijacking by taking some cookies, or even phishing. Then you have CORS. CORS is pretty popular. It says who can access your request, access your resources. It becomes critical in terms of defining, it sometimes even probably prevents DDoS because you're able to say that, okay, this user or this particular resource can only be accessed by this particular website or this particular application. And then something you have final, which is secure cookies. Secure cookies is pretty popular. It defines who, how, and from where can access your cookies that you're setting for your application. I'll not go more deeper into this, but it's a good general idea to understand these 5 different headers that you can set, and the browser takes care of the rest. Okay, now this will be interesting. These are some of my recommendations that you can take back from this session. I think the first thing when we looked at all the vulnerabilities was, or looked at all the common mistakes, I should call it, is how do I test for these, right? Because I gave some examples, probably you guys are not aware of it. One question you'll have is, what type of input do I send for checking SQL injection? What type of request should I send for checking open redirects? Do I just send google.com and see if it's redirecting me to google.com? What about cross-site scripting? And what do I even send? Like, how do I even test for CSV injection? If you're a penetration tester or you're interested in that, you'll have these questions. So my first recommendation, you can take it, you can scan the QR code, is this GitHub repository, which is payload box. If you scan the QR code, and you can take a look at it. It will give you all your inputs that you can use, all your payloads that you can use to test. If you are a keyword tester or automation engineer, this is goldmine. It has a list of all the inputs that you can set for different type of vulnerabilities. I think it covers 9 vulnerabilities from cross-site scripting to CSV injection to everything. Okay. This is my second recommendation, is to use a linting tool. So how many of you use here IntelliJ and VS Code? Okay. Use this tool. घर जाके आज install कर दो. What it does is, it will, in your browser, while developing, tell you issues in your code. All kinds of issues. If anybody has heard of SonarQube, which actually, scans your code and tells issues with your code, it will tell you in your browser while you're developing. And it's there for VS Code and IntelliJ and even Eclipse if you're still using it. So yeah, that's my second recommendation. It supports all kinds of languages. So use it. Code scanners, I'll not go deeper into this. There's actually a session right after this one by Kapil. He has 20 years of experience working in this domain, building security tools. He'll go more deeper into this. But this is a general, something which you can use. From this, I'll focus on SemGrep because it's easy to use. It's just like SonarQube, where you can have code analysis done, some customized rules written to scan your code for better security. But this one is lightweight and easy to install. and does faster scans. So this is a third recommendation. These are only 3 recommendations. If you can go back and implement this, it will help you write code like you're a champ. Okay. With that, there's some dependency scanners. Usually vulnerabilities, like I said, abstraction. So we tend to rely on libraries a lot, but it becomes equally important to take care of making sure that the libraries that you're using are secure. So dependency scanners are some of them. One of the scanners which I'll recommend is OSV scanner. This is by Google. They maintain it and is open source, so you can implement that if you want. Okay. Uh, then there is infrastructure as a code scanners, which means Kubernetes, Docker files. If you have all of those, this will scan them and find out issues with those files as well. Sometimes we have open permissions, or we're not doing something which we're not supposed to. This will scan and tell you all about it. Then we have runtime scanners. Some of these tools you probably have already heard about them. SQL map is a good one. I'll suggest you use that. It helps you with SQL injection, like testing SQL injection in your code. Okay, so that's the end of it. What did we learn? We looked at some common mistakes, common vulnerabilities. Now we tend to miss certain things. If I have to summarize, please sanitize and please validate everything that you can think of. Secure coding is a mindset. I know you looked at some code and tried to figure out what the issue is, but you need to start building that mindset to figure out what exactly can go amiss. We looked at some tools that you can use to help write better secure code. And with that, I think you guys are probably a better aware, or better prepared in terms of when you go back, what do you need to do. And with that, if anybody has any questions, we'll quickly take questions, but I think we are a little over time. So in case if you have questions, we can talk outside. Do we have time? Sorry. We don't have time. Okay, so any questions? You can just meet me outside. I'll be outside, and I'm happy to take any questions. And yes, please scan this and give me feedback on the session. I'll be happy to take any feedback that you have and what I can do to improve this. All right. Thank you.